Hello, Mr. Today I'm going to give you a short lecture about the famous rule called L'Hopital's rule. And this is L'Hopital's rule because it's a French name. So we prefer not to call it LHospital rule or whatever pronunciation we might have. It's a quite nice rule in the sense of it really helps us to calculate some limit questions and make things much easier. Sometimes it's just amazing like how it behaves. But there's also requirement like when you can use it. It's not for free. So now let's recall example of a limit question we probably saw before. So it's limit of x goes to 4 with x squared minus 16 over x minus 4. So how we do this one? Usually we do factorization, right? We factorize the numerator to x plus 4 and x minus 4. And you cross out this x minus 4, you get 8 by putting 4 inside this x. Okay, so the reason we don't directly put 4 in x squared and x because this will give us 0 over 0. You see, this is where the problem behaves. Yeah, and then let's consider another example. So it's x goes to infinity, and let's say it's 1 minus x 3x squared and 4x squared minus 5x. Remember how to do this? We do this by compare the denominator and numerator. We try to guide something for numerator. And we plus something here. And then, because these two terms are the largest, we care about this one. The reason here is because we have an infinity over infinity. Or minus, it doesn't matter because the problem is we don't know how to do infinity over infinity. So the natural question come up, how can we do this type of question? Like when it's 0 over 0 or it's like infinity over infinity. This is the two situation we really want to use L'Hopital's rule. So let me give you the theorem first. So it's a famous rule. That's called L'Hospital rule. It just, if you want to do a limit of something, x to a can be infinity, and fx gx. If you have, if the situation is 0 over 0, infinity over infinity, then you can take the derivative of both sides and do the same thing. And also, if here you still get 0 over 0 or infinity over infinity, you can even go on and on. You can take f prime prime, g prime prime x. Okay, so let's do this two example with this formula to see how it looks like. So we're doing limit of x minus 4, x to 4, and x squared minus 16, x minus 4. So now look, we're 0 over 0. So we can apply the rule, which gives us what? 1 over 2x of 2x, right? So now, here, it doesn't give us 0 over 0 or infinity over infinity. So we cannot apply the rule again. Look, if we apply again, it will be 2 over 0. It just doesn't make sense anymore, right? So this, if we put x to 4 here, we get what? 8. Very quick, right? For this one, it's even better. So if x goes to infinity and for x minus 5x, 1 minus 3x squared, you take the derivative, what do you get? You get a negative 6x and 8x minus 5. So what you have? Look, the interesting here is you still have a infinity over infinity, so you can take it again. And what you get 8 over -6, which just give you -4 over 3. So look, this make our calculation much easier, right? Although you need to apply the new rule that you're not familiar with twice, but it's so much better than what we try to do here with all the factorization kind of operation. And you have less chance to make mistake, right? But remember, you can only use it when it's 0 over 0 or infinity over infinity, or let me plus a sign here. Okay, so this is it for today.